This is a video cast on looking at magnification calculations, which are very straightforward as long as you follow the formula. And the formula that we need to follow is this one. And so before we start, I just want to go through what this says. This says that the magnification, M, is equal to the image size that we see over the actual size of the object that we're looking at. And so with these triangles, I hope you know that you just cover up the one that you are looking for and then read off the other two. So for example, if I was to look for the image size, if I covered up image, I'm left with A and M. So the image size is, because they're on the same line, the actual size times the magnification. If I wanted to do look for the magnification, I would cover up magnification and I'd be left with the image size over the actual size. And you can see there, that's what it says below. So we just have to know that how to use this triangle, and then we have to fill in the gaps. The only thing that we need to make sure of is that we get the units of whatever we're measuring in the same level. And I've got here just an introduction into the units. Now these seem really complex, but they're really not. If we've got a meter rule, okay, let's just say we had a meter rule. Okay, there's our meter rule. Okay. Now, the way we can look at that is we can either make out that that is 1 meter, or if we split it into 1,000, it'll be 1,000 millimeters. Okay, and you know, a meter rule actually is broken into millimeters, tiny little. Okay, that's as small as we go with the naked eye. But when we're looking at biological things, we go much smaller, and so we need to be able to measure them. And it would be crazy to measure something that was smaller than your eye could see in meters, because you'd end up with 0.0000001. And so what we do is we have other units which help us here. So if we were to divide this meter rule into a million, we would have micrometers. Okay, and we write that like a UM. And if we were to divide this into a billion, which is 9 noughts, we would have nanometers. And so all that these are is a way of going smaller and smaller and smaller. The way we write these in terms of, you know this from your maths, we 1, 10 to the minus 3, 10 to the minus 6, 10 to the minus 9. And that means that we have to move the decimal point that many to get to 1 again. So if we have 1 millimeter, it's 0.001 meters. So that's 1, 1, 2, 3 to get to 1 meter. So we can say it's 0.001 meters is 10 to the minus 3 meters, and 0.00001 meters would be 10 to the minus 6 meters. Okay. So now what I would like you to do is to speak to me if this is causing confusion, because this is difficult in many ways to explain, and if you don't understand it, it can really scupper your abilities to get things right. So you need to be brave here and say whether you do or don't understand, and I'll try and think of another way of explaining it. Okay. So if we go back to our questions here, we actually look at question 1, and question 1 says that there is a